Okay, and we haven't had that happen before. Basically, the biggest thing we need to understand is that if I have the same base on both the left and the right side, all you do is set the exponents equal. That's all you do. Okay? Same thing with the logarithm here. If you look here, it says if log x equals 3, then 10 to the log x equals 10 to the third. So it basically means what you can do here is take the 10, that base, raise both sides to it. Those cancel each other out, okay? And you're left with x equals 10 cubed. Okay, and so we're going to look at some of those equations. We're going to just look at a few today. Tomorrow we'll build on that and look at a few more. So first of all, it says solve each equation. So I have 36 x to the x plus first power equals 6 to the x plus sixth power.
That looks different than what was on the other side.
Now, in order for us to set these exponents equal, I have to have the same base. My bases here are 36 and 6. So what I need to do is think of a small base that both 36 and 6 can be written by. And that's obviously going to be 6, right? Because I know that 36 is 6 squared. So hopefully you see what I just did. All I did is wrote 36 as 6 squared. Now, do we remember the rule? What happens when I have a power to a power? What do I do with those two things? Distribute, yep, multiply. So I'm going to take that 2, and I'm going to take that times both the x and the 1. And what does my exponent now become? 2x plus 2. And that's going to equal 6 to the x plus sixth power. Now remember what that first slide said. If they have the same base, what can I do with the exponents? Make them equal. So basically, I get 2x plus 2 to equal x plus 6. And that's just a basic equation that I can solve. So let's go ahead and solve. So let's subtract x and subtract 2. So what do I get x to equal? 4. Okay, if I look at plugging 4 back in here, I get a positive, we're good. And there's your answer. So, that bad? Let's look at another one. 1/2 to the x power equals 64 to the 1/2 power. Okay, first of all right, before you all panic about the 1/2, let's write this another way. Okay, I can write that as 2 to the negative first power. Why? Because it's in the denominator. Okay, remember this is like 1 over 2 to the first. So if I want to move it up, it would be like 2 to the negative first. Equals 64 to the 1/2 power. So if I look at my two bases are 2. It's 64. So what number can both of those numbers be written by? What base? 2. So first of all, what I'm going to do on the left side is I'm going to go ahead and multiply the -1 and the x together. And I get negative x, right? 64 is 2 to what power? 6th, you're right. So, how do you know it's 6? Because 64 is actually 8 times 8. 8 is 2 cubed, 8 is 2 cubed, 2 to the 6th power. Okay? So then now, real quick, let's go ahead and distribute 6 to the 1/2. And what do I get? 2 to what power? The third. So then now I have the same basis. What do I do with exponents? Set them equal. So negative x equals 3. What do you do now? Divide by -1. So x equals -3. We're gonna look at one more today, and then we're gonna call it good.
See, that was different than what we were doing before. I think she's just trying to see.
It's actually not. It's not that bad. Okay, as you're writing that down, I want you to look at the numbers in the parentheses. And I want you to tell me an observation that you make between the two.
You can like cross them or something. Flip 2 and 4 and 3 and 9. Or flip.
If you flip, okay, so real quick here, I've got 2/3, right? And I've got 9/4. Okay, let's think about what a base would be that would be in common with both.
12.
Yeah, it's actually 2/3. Now, for those of you wondering where on earth did that come from, I'm going to look at this side first and write it down. And then I'm going to come over here. Okay. What do you know that 9 is? 3 squared. What do you know that 4 is? 2 squared. Okay, so we're going to come back to this in a little bit. All right, so first of all, I'm going to go ahead and leave the left side 2/3 to the x minus 5 power. Leave that alone. This one, do you remember how we flip things? What do we do? Make it negative. So really, this would be 2/3 squared, right? Isn't it 2/3 squared? Actually, to the -2 power. Okay, because the negative takes care of flipping it. And notice I had a 2 squared and a 3 squared. And then so now, out here I have 3x divided by 4. So really, what do I do with the -2 and the 3x divided by 4? I distribute. And so if I take -2 times 3/4, what do I get? Which is -3/2x. Okay? So on some of these you might have to be a little creative. Alright, so I get x minus 5 to equal -3/2x. I'm going to go ahead and just move over the x. So I'm going to subtract x from both sides. So I end up getting -5 to equal negative. How about -5/2x? For those of you wondering, this is -3/2, right? This is basically -1, which would be -2/2. So -3, -2 is -5.
Oh, okay.
So then now, in order to solve it, I'm going to multiply by -2/5. What happens to your negatives? They cancel. And then, what happens to your 5s? They cancel, and so your answer is? Answer isn't cancel, it's actually 2. Okay, so now that one was a little bit tougher, I'll give you that. But here is the start of your assignment, page 196. And I would like you to do 1 through 8. If you work, you probably should be able to get done with that today. And then we will focus on the second part tomorrow.